Hello, I'm Vic Kelson. I'm the Executive Director of Evansville Water and Sewer Utility. With me, I have Justin Getling. Justin is the Deputy Director for Field Operations here at the utility. We're here today to explain what's going on with the sinkhole on Riverside Drive. We finally decided that this is a complicated story that's going to take a little bit more attention and a little bit more explanation for you all to understand it. We want everyone to understand what we've been dealing with and what our plans are for going forward and getting all of this repaired. So we'll start out. Justin, you have anything you'd like to share about all of this?
Well, first, we'll just go over a recap of how this and when it started and basically where we're at today. So basically about 5 months ago, we got a phone call from downtown to the utility about a sinkhole forming on Riverside Drive, impairing traffic going in the westbound lanes. Come down to investigate. Yes, there's a dip. We need to get some locates called in, dig some things up because we've got several different utilities in that location. Got everything dug up. Noticed that it wasn't the water main going down one of the streets. It was actually on Chestnut that was causing the ground to undermine. At that point, called in a couple other contractors, got down inside of it, saw that it definitely was the old brick sewer main running down Chestnut. So that took about a month. And then at the end of March, we were close to having this completely repaired. I think it was about the 25th, 26th of March. We were going to put in a 48-inch steel casing inside the old brick sewer main, grout around it, backfill, line it, good and out of the way. Well, then the weather changed. Something we cannot predict, something we had no control over. Mother Nature is Mother Nature at that point. So, as Vic will mention later with some illustrations, it really put a damper on how fast and how safely we could repair this. Well, fast forward another month, another rainstorm comes in, starts washing a little bit more out where we're waiting on the river to go down. Now it's kind of slowly, cracks in the street have shifted over into the eastbound lane. So now we're having to close both lanes of traffic, east and westbound on the Riverside, making a huge detour down around 2nd to Cherry. So once again, time, waiting on weather, for the river to go down so they can safely go down, excavate, do the repairs that need to be done, and basically start to backfill. In that process, storm comes in on a weekend, undermines a little bit more, busts the water main, the 10-inch water main that runs up and down Riverside. After we had cut it out of the way once to prepare for our contractors to put in shoring, it broke. So now we're fighting not only the river water, but also the water coming out of the water main. So we get that repaired. Once again, more and more undermining, which is making it harder to deal with. Finally get a plan in place, and this time we're just waiting on basically Mother Nature for the river to get down to a manageable level so the contractors can get in there and do the repair.
So what I'm going to do next is I'll get up to the whiteboard where we have some cartoons or illustrations of how this system is all structured over there. And I'll explain as best I can a lot of what Justin said to try and reinforce how this all happened. So here's an illustration of how this whole system is structured. This is a plan view from above. And I should put directions on here. This direction is actually east, this is east, and this is west. And this direction is north and south. And the river is over here. So when we look down at this intersection, this is Chestnut coming in from the north, and it intersects with the westbound lane of Riverside Drive. There's a traffic island between the eastbound and westbound lanes, and this is the eastbound lane. So that's the purple lines, or the road. The green lines are the sewers. These are sanitary sewers. Actually, they're combined sewers. It's both sanitary flow and storm flow. This is the sewer that failed. It connects at this manhole with the sewer that goes from west to east and flows to the east wastewater treatment plant over on Waterworks Road. There's a diversion structure underneath the eastbound lane of of Riverside Drive. Over the top of it, there's actually a water main that runs above the diversion structure. It's like a big tank underground. And beyond that diversion structure, water's able to flow out into the river when we have too high of a water level in the sewer. This is called a combined sewer overflow. We try to prevent those as much as we can, but this is to prevent water from backing up in the sewers. So normally, sewage comes down Chestnut Street to the manhole, enters the sewer that's headed for the wastewater plant where it goes to be treated. Now in cross section, we can look at it here. So here is our sewer. This is a 48 by 56 oval sewer manufactured by hand from bricks that's been down there for well over a century. What happened is, so it goes underneath. This is the manhole structure that sticks out above the traffic island, and then the diversion structure that allows water to flow on. It's basically a valve here that allows water to flow on to the river. Up above this, there's a 36-inch water main, a 30-inch water main located here, and a 36-inch water main located over there. And Justin mentioned a water main that broke. There's a 10-inch here. This one is a 30, as I said, and this is a 36. Now, this main actually distributes water along businesses and so forth along Riverside Drive. From that, there's a 6-inch line that goes to a fire hydrant. On the other side of Riverside Drive, that also supplies the pagoda. So this whole, in cross-section, the system looks like this. Now, what happened back in February when all of this began was a hole opened up in the top of this sewer, and the material, the bricks and so forth, all collapsed into the bottom of the sewer, and it opened up a hole. When that happened, the fill material that sits on top of the sewer also began to fall into the hole. And when this happened, we started to get the collapse that happened in the westbound lane of Riverside Drive and extended down Chestnut Street. Now, this was patchable. This could have been repaired, as Justin said. So when we began all of this, we saw this as a repair, a point repair. We do these all the time, not usually this deep underground, but we do these all the time. And we saw it as simply a repair. Now, to do this, though, we had to have a shoring box that went down more than 20 feet, 25, 26 feet down to get to that sewer. So we had to shore this box up all the way down there and dig to get to the sewer to inspect it. And this is what we found. Now, we did use the television camera and we did do physical inspections along here and found that the sewer was intact over here and over here at the time. Now, what happened then was in April came not only a lot of rain, but a lot of rain over a really large area, and the river stage raised from the 18 to 23 feet that it was before, it got all the way up to 48 feet, which is the second highest river level ever experienced since we've been recording it. What happens when we get into this situation is the water levels, the groundwater levels throughout the subsurface here and underneath the levee, those groundwater levels will rise up to match the river water level, which means that if you were a person who was working in the hole when the river came up, there would be water cascading into the hole, and the hole you could be drowned. It would certainly disable your ability to work. So the river level has to stay down below the bottom of the excavation, or we can't work there safely. When the river came up in April and stayed up for a while, it came down and back up and down and back up, and we've continuously been watching it, looking for it to get below 23 feet and stay there. Normally that happens in the summer. It can go most of the summer in 17, 18, 20 feet of water level, but that's not where we are right now. So what happens then is when these groundwater levels got to be so high, and there was this additional pressure of the water pressure at the levee, what will happen is the kinds of sand and silt that our subsurface here is made from become it's the process called liquefaction. As they get wet, they start to become slippery, and they will tend to flow when you put additional pressure on them. So what ended up happening is when the river stage was up and stayed up for a long period of time, we started to see soils moving and sand moving in the subsurface towards the hole because there was a place where it could get out. So that soil was just flowing towards the hole. When that happened, this manhole began to tip over. So this manhole was compromised. This diversion structure has also been compromised. Everything is moving with the sand as it moves. Now, where does the sand go? Well, it ends up in the sewer and goes to the wastewater plant. And we've got pictures, we'll put them in the video. We have pictures of that sand where it's being captured in the grit chamber at the wastewater plant. And it's an impressive amount of sand that has been washed out of here and taken to the wastewater plant. The other thing that happened is, as this all began to subside here, that put additional strain on these two water mains, especially the 30-inch one, which one of the bell joints in that has actually started to drip a little bit. So we've had to do a repair on that to make sure that that doesn't break. These two water mains provide almost all of the water to the west side. So without those water mains, the city's in a lot of trouble. So what we're seeing here is, over these months since April, when the river first flooded, this has continued to occur, and it continues to subside even as we speak when the water levels in the river are high. Now, hopefully, they're at 24 and a half or something this morning. Hopefully, they'll be down to the point where we can work again in the next few days, and we'll begin working as quickly as we can. So now I want to talk about what comes next. If you look at our illustration, you'll see that I've now drawn a jaggy-looking black box across Riverside Drive in the illustration. That is a box that's we're going to be constructing. Contractors will be out there starting next week, we hope, installing metal shoring that will go all the way down to the bottom of the hole. That shoring will be used to support the sides of the hole so it doesn't cave in when people are working in there. It will also reduce the amount of material that needs to be removed from the hole. Just to give you an idea of what we're dealing with in terms of the magnitude of this effort and the cost of this effort, was told yesterday by our contractor that once this is done, if we were to fill this up with the white gravel that we normally use to fill holes, there would be $1 million of rock required in order to fill that hole. It's a big hole. It's 20-something feet deep. It's more than 100 feet long, and it's probably 10 feet wide. So it's a big hole. They'll be installing that shoring and excavating the entire system there. We will be adding support bracing for the water mains so that they don't collapse, and we will be removing the damaged manhole and diversion structure. Only once we actually get down there will we be in a situation where we have the information needed to design the new diversion structure. So we're going to be doing the repair and designing the repair at the same time in some ways. Sean Wright, our director of planning here, has the phrase he's been using is, this was originally a repair problem and now it's a major project. We don't normally do major projects in real time with the street closed, doing all the design as we're doing the work. We normally would have taken our time to do this, right? And we just never have had that opportunity here. It makes it harder, it makes it more expensive, it potentially makes it less safe. So our first priority is making sure that our workers and the public are safe as we execute this project. So we're going to be shoring up the hole, we're going to excavate everything, and then and there will be fencing and so forth around the hole to prevent the public from getting in there. We ask you to please have patience with us as this proceeds. It's going to take a while, possibly 3 to 4 months. The best estimate I've seen is that we could be complete and have Riverside Drive open in October. That's a big problem, and it's a real disruption for the public, and we apologize for that. But as Justin said, we were not able to control any of the things that led to this. So on the 4th of July, we will have some security folks there to make sure that anybody who might get over there is reminded to stay away from the hole. I'm asking you now to stay away from the hole as we get going with all of this, and we will keep you updated as we go along. This is a a real challenge for us, but I'm confident that when we're done, we'll have a better system there. Our intention is to rebuild it so that we don't have to deal with this again for another more than 100 years in the future. So the other thing I'd like to say is that within the portion of Riverside Drive that's closed right now, there are 2 more similar locations, and we've got an inspection contract with a local contractor. They will be going out to inspect those sewers to make sure that they're in good condition and determine whether we need to do sewer lining projects on them as well. If we have to do any kinds of repairs or sewer lining projects on those sewers, we'll do them at the same time that we're executing the big project at Riverside and Chestnut, because we don't want to close everything down again. So thank you for your attention, and I hope this is very helpful for you. Please share the video with your friends and colleagues, and if you have any questions at all, please reach out to communications@ewsu.com.